thanks a lot. First of all, yeah, it's really nice to be here, and it's quite, yeah, for me a little bit exceptional. So usually I tend to talk a lot, you know, or give presentations a lot, but this is something that also gets me a little bit excited, this event, so the Chaos Communication Congress, and I hope now for the next hour or kind of 45 minutes I'll tell you something you find interesting. Today I want to talk to you about towards a cognitive quantified self, so activity recognition for the mind. Some background about myself. My name is Kai, as mentioned. I'm enjoying living in Osaka in Japan for 1.5 years now. And beforehand, I did my PhD in Passau in pervasive computing. And what I want to talk to you today about is, first, I'll give you a little bit more background about my previous work, so in physical activity recognition, and why I believe that it's slowly becoming mainstream, so more and more people using it. And then I will talk about a new kind of research direction, so towards activity recognition for the mind. And we in Osaka picked a specific topic out of the cognitive tasks, and this is reading. And I'll give you a small introduction why we picked just reading tasks, and then get into some of the questions we ask, you know, kind of how much or what are you reading, how to do reading tracking of reading habits during everyday time, and then hopefully at the end, and this is also why we took a bit longer to set up, I can show you some demos. Seemingly the iPad doesn't like the VGA connection to the projector right now, so I have to hurry a bit. My previous research, or a lot of the things I'm doing, is in the pervasive computing area, and in this case we really believe that if we are getting more and more personal with computers and have more and more devices around us, the interface has to vanish, because the limiting factor is no longer CPU speed or memory or even battery life, but the limiting factor, if you have computing very close to your body or in your environment, is actually human attention. And so the interface needs to vanish, and computing needs to become proactive. This means computing needs to sense what people are doing or what they're doing to enable context-aware systems. And one of these enabling technologies is activity recognition. And if I talk about this, I'll just want to give you briefly a small application scenario. This is a video, relatively old one. Sorry for the video quality, of a maintenance worker, and this is kind of usually how he does his job. You have the manual, and the expert comes to a machine. The machine might be 20 or 30 years old. Although he's an expert, he does not know, you know, the inner workings of it. He has to read a manual. Usually it's a 500-page instruction set, and he has to always switch. He has to do this context switch between the manual reading, what he needs to do, and then his actual work. And what you could imagine already today is just using a heads-up display, and then you get rid of this context switch, but still you have to manually advance the instructions and browse the instruction set somehow. So what you really want to have is a system that directly supports the worker doing the maintenance work, and in this case recognizes an error. You get feedback on the display that a cabling error happened, and as soon as the maintenance worker fixes the error, the display turns normal again, and also advancing in the instruction sets or so on are done automatically. And this is not only a nice kind of scenario, what we mean with living with computers or computing helping us in everyday life, but this was a user study we did at SAIS with 19 trained professional maintenance workers that were no volunteers. So they were quite critical at the beginning using this kind of system. Most of the sensing was not really implemented. This is called kind of Wizard of Oz study. So we focused on the interface. But at the end of the study, they really asked about, when can we use this system? And at the time I was a PhD student, and I had to tell them, it's kind of research, and I'm not sure what's coming out of it. So if you're interested in this kind of work, there was a talk 5 years back at the 25C3 where I talked about this scenario and a little bit more. But if you want to implement this, we need to have sensors embedded in the environment, something like a 3D camera, like the Kinect, or a microphone array, or also something I specialized on, sensing on the body. And here you see also some old recording about doing some exercises in the gym with accelerometers. They are mounted on the lower arm, on the upper arm, in the trouser pocket. And what you can already recognize in the signal is kind of, in both signals you can count the repetitions, and if you would see different machines, it would be possible to distinguish different machines and so on. So you could do tracking, although you also see some problems. So you see these bandages which don't look pretty cool, and also that the signal, even though on the same kind of body part or slightly shifted body parts or lower arm or upper arm, for an accelerometer distinctly looks different. And you have to deal with this somehow if you want to recognize activity. And also, as I mentioned, all the cabling and so on, it's not the nicest thing to wear. And can you imagine wearing your grandmother wearing this kind of sensors? Yeah, maybe if you're doing a PhD in wearable computing. That's, by the way, my grandmother actively supporting my research. But you want to have the sensing integrated in everyday objects in general, at least. We actually get back to my grandmother later on. So today, now we really have this case where we have sensing embedded in everyday objects. So our smartphones right now have the sensing capabilities we used 5 or 10 or so on years back in the lab, the dedicated devices, the accelerometers and so on, and gyroscopes, inertial motion sensors are really high quality in these devices. And we get more and more of these, and you see the first applications that do activity tracking, commercial applications and commercial devices, especially in the health and fitness area. And kind of from simple step counters to also some iPhone applications that tell you how much cycling you did or how much you used your car to go to work and things like that. And we see also already some commercial devices that move towards physiological sensing. So one example is the Withings Pulse that has a small heart rate monitor. This is also a step counter and has just a small LED in the back and a heart rate monitor, so you can monitor your heart rate. Or also there are a couple of sleep trackers. So honorable mention is for the CEO Sleeping Coach. The company, I think, went unfortunately bankrupt 2 years ago. But this was kind of a nice device because they were very open to hackers. So you could just use a modified USB cable in the back of the device, and you could connect it to a USB host, and then the USB host could live tweet your sleep cycles and stuff like that. Yeah, now I got also excited about this Kickstarter campaign about the sleeping mask, NeuroOn. This is a polyphasic sleeping mask that measures using EEG and other sensors your sleep phases. And we're slowly approaching a time where we can extend this to cognitive tasks. And in research, we want to be a little bit further out from commercial appliances. So I thought, can we do something like cognitive task tracking? And the first approaches, or there's also work in cognitive science, and if you look at it, the obvious approach is, can I directly tap into the brain, like a brain-computer interface or so on? Now, however, if I looked at the devices, the drawback is a lot of them are quite obtrusive. So if you talk fMRI, you need a whole room, and it's quite expensive, so nothing you can carry around, and also you're talking about really strong magnets. And then more interesting I found were wearable devices like EEG or fNIRS But still, there you have to do a lot of processing, and at least my experiences so far with it, although I'm quite naive towards this technology, is that it's very user-dependent, and also, especially EEG, reacts quite bad to motion. So if you have motion artifacts and other things in there, and the other approach is to use secondary sensors, like galvanic skin response, or also maybe motion sensors. And one that seems to work especially well is using eye gaze. So using some kind of eye tracking. There are two fairly prominent ways to do this. One is electrooculography, EOG. Now, this is more or less using the same principle as EEG, so you attach electrodes to the eye, but in this case you don't really measure brain waves, but you measure the eye as a dipole, so you measure the eye movements with this. There's a good reference if you want to go into this, and I think you can use the same hardware people use to build EEG devices to set this up, and the other is optical. So here you see one of the optical eye trackers we use, usually with infrared light. This is an SMI mobile eye tracker, so one of the devices we use also later for most of the experiments I will refer to. And what you see is it uses active infrared light sources. If you see 6 or 5 in each eye, the tracking is quite accurate and quite high. The problem with this is, of course, these experimental devices are a bit expensive, and also you need, of course, more processing in comparison to EOG. And then if we have these kind of devices, then the question comes, where do we start? And we picked trying to track reading habits out of the following reasons. There are a lot of cognitive science studies that try to tackle reading, but there are very few in situ studies that explore reading for, in quotation marks, normal humans. So there are a lot of studies with infants, or also with people with dyslexia or mental illnesses, but very few that give you information about what are healthy reading habits. When I want to really remember something, when should I read it? And also, if reading is one of the primary learning or knowledge acquisition tasks. And we have these studies that show that people who read more seem to have higher vocabulary skills and seemingly also higher general knowledge. But a lot of these studies, rely on questionnaires and so on. And I just wondered, also maybe there's some, I see at least 1 or 2 PhD students here. And I also wondered, what happens if I copy the reading habits of my thesis advisor, and will I become a better researcher or maybe not? And so on. So the first thing we started, Koichi Kise, the head of our institute, started with the reading live log. So we have some character recognition and also document image retrieval techniques in the lab. And document image retrieval kind of works. Character recognition in scene images is an unsolved problem, but document image retrieval works relatively well. What you do is you register the document beforehand, and then if you use a scene camera, you can easily recognize the document in very fast way, and even for a large set of documents. So even millions of pages are not a problem, and if you have a large enough server or a big enough server, you can kind of deal with Google Books size corpus or so on. So this is not a problem, and you can attach eye tracking to it. And what you see here is some recording of a student of us. He's reading the document. You get the retrieve page over here, and then can match the eye trace because you have the scene camera from the eye tracker as well. So you can kind of also stabilize the eye trace over here, and you can really record each word the student is reading in this case. So maybe later on we have some device that will record every word we read during the day. But we also wondered, what can you do without using the scene camera? So what can you do with eye trace alone? And also if you don't have something like document image retrieval. So these are the 3 questions I'll try to handle during the remaining talk. So can we deal somehow? So maybe I should be a bit anticlimactic. So we haven't answered any of these completely, of course. But we try to work towards this and give you also tools, or try to provide you with tools that you might be able to do tracking reading habits during your everyday life. And so how much are you reading? For this, we implemented using eye gaze, a wordometer. So analogous to the step counter, we just thought, okay, if step counter helps for your fitness life, maybe a wordometer can help you for your knowledge life. And using eye trace, we estimate the number of lines. So first you do a reading recognition, a reading detection, and then we estimate the number of lines, and then you can estimate, of course, the number of words read. Here you see again, the eye tracker we use, mobile eye tracker with the infrared camera, and here you see the projected eye trace onto the document. These little circles are fixations, and the connections between fixations are saccades. So rapid eye movements, and then always the fixations on the words. And what you usually have for a line is you have a number of fixations, and then a long saccade towards the new line. Japanese is a bit more difficult because you might have, or in general Asian languages, or Chinese as well, because you have changing reading directions. But in general, it's relatively easy to do reading detection and recognition, and then afterwards you just have to look for these longer saccades. You have to do some little bit of filtering, but in an experiment with 10 users, around 14 documents and natural reading, we got an error rate between 8 and 13%. So the current, I think, pedometers are around also 5 to 7%, so it's comparable. So it might help you with your knowledge life and getting some more information about how much reading you're actually doing, or how you compare also with other people. And then the next question, what are you reading? We already saw the document image retrieval with the eye tracker together, but can we now also distinguish document types using eye gaze? So in this case, we also recorded some 10 users with 5 different document types. So here you see manga, novel, magazine, textbook, and a newspaper. And as long as the document types are different enough, so text layout and the number of images, as well as text or reading direction are different enough, we can do a fairly good job. So we are user independent with 74% and user dependent with 98%. This is kind of a sliding window approach. I'll show you a little bit later what kind of features we used. Interestingly, why we are so bad in the user independent case is for the magazine case, we had 2 male subjects that were just reading the magazine, the fashion magazine, because they were not really interested in the pictures, so they started reading it line by line. So next time, and also if you're working with eye gaze, it's important that you have to have the goal in mind. So also our eye gaze is very, very directed towards the goal. So if you tell somebody just read it, it's maybe not a good idea. So in this case, this is also why we couldn't really use a lot of the fixation features. And these are the examples for the different eye gaze patterns. So here you see the textbook. This is an eye gaze pattern for the textbook, for the novel, for the fashion magazine, for the newspaper, and also for the manga. And as you can recognize, they're fairly different. And if you have more images, of course, you have longer fixations, and also reading direction and so on is different. And now I want to quickly switch to a small demonstration. I'm not sure how many of you are familiar with IPython. And quite a lot. Okay, IPython notebook as well. Yeah. Oh, good. Yeah. So more or less, I ran into it a couple of years back, and since then, I have to switch to the project. Since then, I'm using it. Beforehand, I used mostly MATLAB, and since then, I'm using it for the document type analysis. So if you're familiar with it, you can use Markdown to write an introduction or so on, or what you're actually doing, and then just Python code, and you can execute it in a browser, kind of, you can execute it by Shift-Enter, and you can, in this way, explain your code quite nicely. You can also join R code or JavaScript code, and here I'm currently reading in 3 files, so one for the manga, one for the novel, and one for the textbook, raw data. So this is kind of how the raw data looks plotted directly out of the file, what you get from the SMI eye tracker. This is just line by line the coordinates, and if it is a fixation or saccade. And what you want to do, you want to clean it up a bit, because what you always have, if you fixate somewhere, you have really small eye movements. So you have fixations around a point. You don't really fixate one point, but you fixate around it. So you want to combine all these small fixations around the point into a larger one. And then if you do this, the filtering, by the way, the code is also up on GitHub, so you can later on check out the code. You first get this. This is kind of a clean data, but I don't include the duration of the fixation yet. And then if I include the duration of the fixation, you get the nicer plots we had before on the side. And then you can also recognize or distinguish the reading types. And then to do classification, you need kind of to do a sliding window. In this case, I did a relatively easy time series approach, a sliding window, counting just the saccade directions, so saccade up, saccade left, saccade right, saccade down. And if I do this for the 3 document types, what you can see is, of course, the novel is up here because it has a lot of saccade down because the reading direction is different and so on. And of course, this is a very simple dumbed down version of what we did. When I can get my, here's my mouse, okay. But it gives you an impression kind of how to do this analysis, and I'll give you some other info and hints about IPython notebook and what kind of packages we are currently using, and also some more general hints about how to do research and how to organize especially data folders, because it happened to me quite often that I overwrite, that I at the beginning overwrite some important data with aggregated data, so didn't keep the raw files, and this is bad, so you shouldn't do this. And then the last question I want to tackle today is the most interesting, but also the most difficult one. This is, how much do you understand while reading? And here we try to estimate reading comprehension. So we gave people just a standardized comprehension test section, and from the TOEIC. TOEIC is the Japanese equivalent to the TOEFL. And people read it with a mobile eye tracker, answered questions afterwards, marked difficult words. And we were not able yet to estimate the TOEIC scores. We want to do that because then later on you don't have to answer questions anymore. If somebody asks you about your language expertise, you can just read a text, and afterwards you know how proficient you are in the language. This sounds a bit scary, but let's see if we can get there. But what we could do is we could figure out difficult words. And this just worked on the fixations. So just using, again, red are fixations and blue is saccade. And then we do a horizontal projection towards the line, the user read, and then just a histogram of the fixations tells you which word is difficult. In this case, mortgages was not understood by the reader. So we are working on that. And I think also while looking at the text, especially English is interesting because we had just Japanese readers. And you see with not so good Japanese readers of English text that they mimic the Japanese sentence structure. So they read the sentence first, and then they jump back to the subject, and they will look at the verb at the last part, because in Japanese the word comes last. And this is interesting. So I'm wondering also if you can do classification of a personal background by looking at how you're doing reading or how you look at something in general. I mean, this is not limited to reading. And then, for future work, maybe this is, I just took the Fitbit page and changed it a little bit. So you have words read maybe, and you can share with your friends how many words you read during the day. For the quantified self people, I'm not so sure if it's such a nice vision to have and see what type of reading you're doing, and maybe the professor can see, how much mangas and how much science papers the students are reading. Or concentrated reading, or how much in the different languages you do. I think that's slowly possible with this technology. There's one problem, although this is eye tracking hardware so far is quite expensive. But if you look at patents, especially from Apple, Google, and Samsung, maybe the next version of Google Glass or similar product will have eye tracking already implemented into it. Now you might say, oh, I'm not so sure if I want to run around with Google Glass, and it might be a bit dorky and so on. And I promised you I'd come back to my grandmother. Even my grandmother is wearing it, so I think it's okay and safe. By the way, my grandmother and grandfather had it for a day and used it, and they really liked it. And they have a good track record for technology, so I was quite surprised. So they liked the DS and the Wii and the iPhone and the iPad so far. So yeah, let's see. I'm not so convinced, but let's have a look. So I have one of the devices actually here with me. And I can show you a small demonstration if you want to. So one thing is, if you look at it, you can always see if it's on. And if I now, OK class, take a picture. Take a picture, you also see, that I took a picture, and you maybe also heard the sound. So at least privacy-wise, I think you can get spy cameras on Amazon, way easier, that can take way more creepier pictures than having somebody, that takes pictures with this. But I kind of understand also. I mean, at first when I saw the device, I thought, why put the camera on the outside? I want the camera that points towards the eye. But for one thing, though, yeah, I mean, but this is just my personal, preference. So I understand why they put the camera on the outside. And also, warning, you void your warranty if you do stuff like that. But big kudos to the people at Google. A lot of them are also from the wearable community, so quite close to people I know, or also kind of from conferences and so on. And they made it really easy to hack it. So you can unlock the bootloader, you can easily get root on the device, and you can flash easily the firmware, the factory firmware back onto it if you nearly bricked it, which happened to me twice, and I was kind of a little bit sweating before the talk because I was not sure if it's working. So thanks there. But as I said, kind of, why did you put the sync camera into it? I wanted the camera that watches the eye. And also then I made a little privacy enhancer while I wear it here at the Congress, because I know people are, privacy aware here, and I don't want to be running around pointing a camera at somebody. So later you'll see me, if I wear it out, you'll see me wearing this. It's done with a 3D doodler relatively quickly, and the problem is you need to spare out a little part at the bottom because there's the light sensor for the display, and otherwise you cannot see anything in normal lighting conditions on the display. But yeah, now I want to quickly show you a demo that Shoya hacked together. And wait, first, yeah, I'm root, so first I have to give you a screen, so this might take just a bit. Here. So yeah, if I do this, you see my screen. So OK class, take a picture. You see the interaction, and you have this sliding view. So, wait, I have to wait. The sliding view. So this is kind of my Google Now thing. So weather forecast and stuff. And back you see kind of pictures I took. And what I want to show you now is they have actually something pointing towards the eye. It's just a proximity sensor, but if you root your device and void your warranty and might brick your device and so on, you can hopefully it runs. Yeah. You can run why is the sensor signal not showing? Maybe I have to wait a bit. So what this is currently doing is counting my blinks. It has a little proximity sensor pointing towards the eye, which is just infrared. Sometimes it's not working so accurately. And also if you give a talk or so on, your blinking frequency is higher. Now it shows the graph. It's relatively chunky, but if I blink, you see the spike down. Yeah, and it's working, okay. And I've already thought about applications. Of course, if I move my head, and especially if the lighting condition changes, you will also see some recognition of false blinks. But you get the idea. And I think this is a good point why you should wear glass while driving, because if you have an app that can detect if you close your eyes for a longer time, I think this is quite useful. And it should not be banned from driving, but people should think about, kind of interesting applications you can do with it. So that's that. So now I can get back to the slides. And I'm also wondering now that you have an IMU, so now you have an accelerometer, gyroscope, and magnetic field sensor strapped to the head of a lot of people, at least not so many, but maybe later on more, and also this proximity sensor, what kind of things can you do towards cognitive task tracking. Then I also want to mention, because I was with eye tracking and how expensive it currently is, at least SMI, eye tracker, and other commercial solutions. There are a couple of open source eye tracking efforts out there. I haven't tried those, but I just wanted to give you a list of things I know about. And of course, also you can build your own hardware. And there are 3D printed versions and so on already out there. You can also mount on Google Glass, a small webcam. But why can't we use commodity devices to do eye tracking, maybe some low fidelity eye tracking? Because a lot of the devices here have a front-facing camera. And maybe we can do something with it. Not as nice as the infrared stuff, the infrared cameras, but maybe. And now I want to ask Shoya if he can maybe give a demo about what he's currently working on. Okay. And I should mention, so Shoya is last year bachelor in Osaka Prefecture University.
Hello, my name is Shoya. I'm a student of KAI. And today I want to show you the demonstration about our application, which tells us where we are looking. It's very delicate. I see.
It doesn't like iPads. I wonder about this connector.
Here. I see.
Yeah, it's not a bug, it's a feature. Please. No, okay.
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 It's okay. Okay, thank you. So I will show you the demonstration. It's very delicate. So now, so
This is.
okay, I will show you the eye tracking on iPad. Now, this is the calibration term. I'm looking the orange balloon, and application is running my eye gaze status. Thank you. Oh, succeeded. The blue point is my eye gaze point. So now I'm looking the chameleon's image, and I'm looking the second paragraph. Oh, can you see? Oh, I'm sorry. Yeah. So now I'm looking the bird image. So if you want to try by yourself, please catch us at the Congress. Thank you.
So thanks, Shoya. Although, with technical difficulties, but you can also later on try it out yourself. And we're really trying to open source this after some point in time. Currently, it's really working very well for Shoya and a little bit for me, but we have to extend it for 2 more people. No, the trouble is actually not so. So eye detection works really stable and good, but the problem is doing the estimation on screen. And especially if you move your head and also if you move the device. There are a lot of tricks we can do, but this is something we need to work a little bit more on. So I had a backup video just in case the demo fails, but you saw this. And this kind of brings me also to more or less to the end of the presentation. And I just included one slide to thank all of the people that were involved with the research or in the community, just to give you also a feeling for, I'm just now standing here presenting this stuff, but new ideas don't come out of a vacuum, and it's always through discussions and through a living community. And I think especially in the pervasive and wearable field, we have kind of a good community, and it always feels also similar to what I have here, kind of visiting the Chaos Communication Congress, or also just listening to the talks here. I always feel energized and motivated. And sometimes, especially if you look at the world news, you can feel depressed at some point in time and just think, why am I doing this? And a lot of, or if some people take technology and use it for, mass surveillance or other things that were not intended by maybe the people that envisioned it and so on. So this gives me energy. And another kind of special thanks, sorry for the 2 thank you slides, but this is important because these are the people that actually did the work. So, I'm just presenting here, and especially Katsuma Tanaka, who cannot join, and Shoya, you already saw on the floor. They are excellent students and also excellent hackers. They are also doing a lot in iOS and mobile hacking, and you should Google their names maybe and check out some of their private projects and so on. But also to the eye tracking students, so Yoshimura, Wakana, and Kawaichi. They know anything about mobile and stationary eye tracking and how to filter and enhance eye gaze and classify it and so on. And then, because I'm German, I also want to leave you with a German sentence, viel Spaß am Gerät, you might know, and I wish you that you have fun with technology the next year or the coming years. And also thinking about, how people could misuse technology. And if I'm talking to you, I'm talking to the people that are the living lab. If we think about something or people publish something or do research, you're the first ones who try it, or even research yourself or build stuff. And you're also the first ones that come in touch with problems that this technology might have. And you have to speak up and tell us or other people also what you found. And I think it's important that we exchange, and also that the research community sometimes listens a little bit more to what's going on in the hacker community to prevent these bad or dystopian futures and have a brighter one where we can really have fun and with technology. So this brings me to the end of the talk. So now if you have questions, remarks while in descent, there's also my email address. So especially if you're interested in maybe speed reading or knowing a little bit more about your reading habits on tablets or so on, send me a mail. We might have a prototype maybe mid of next year or so on about a speed reading app we developed together with University of Stuttgart, Tilman Dillinger and Niels Hense, who's I think also here somewhere. Yeah, back there. And also 2 shameless advertisements. So there's Augmented Human Conference in Kobe this year, and I just included this because we have a keynote talk with exoskeletons. So that's pretty cool. Nothing to do with the talk, but Okay, thanks a lot. So now if there are questions, also catch me. I'm here the whole time during the conference, and if you want to talk about things. So thanks.
Okay, yeah, thank you very much for the talk. I have one question about what you can already see from your data. Is there a relation between reading skill and comprehension of the text? So do people who read faster have less words that they find difficult in the text?
Yeah, so I mean, I cannot talk too much. I mean, we just started with the research and I cannot talk too much. So one thing we saw was, of course, people who have trouble with text comprehension usually also go back. And then what I talked about was this effect of the Japanese speaker, that they really search for specific words or so on. And what you see also that people who have good text comprehension, so for the first reading part, if you wanted to estimate a TOEIC score, which didn't work really well, a good estimator was just time. So how fast is somebody reading? And the people who read relatively fast were also the better students. The problem then was that our spread of TOEIC score was relatively limited because we had first students and they have a certain, kind of score, so it's hard to tell. So we had to try to find also people who are a little bit worse or really, really, really good. And not to have native speakers, because then you get this trouble with cultural background, because I think it matters a lot in which language you're native and in which you're not for this task. But yeah, this is something where we want to get at, and especially this is the interesting stuff that gets towards the speed reading app. What happens if you read faster and faster and faster? At what point do you lose text comprehension? And how can you get a reading pattern that is really, really good to do some type of reading? So if you want to understand a specific fact, what type of reading pattern should you use to get this? So this is something I find intriguing, and especially also how to measure text comprehension, because it's not so easy. You might say, oh, I just ask questions afterwards. So then the problem comes, if you, for example, take a Dan Brown novel, somebody read one Dan Brown novel, and you give him a second Dan Brown novel to read and ask him questions about it, he might be able to answer the second questions. But there's this trouble, yeah.
Yeah, rather a technical question, I guess. On the wordometer thing,
yep.
I was wondering why you have to estimate the words, because it looked like in the text that the person stays with their eyes on the first part of the word longer and then jumps to the next word. So I was wondering if you could also take like the jump to count the words and not the lines.
Yeah, so the problem with this is this depends highly on the skill of the user. So first we try to use fixations, but if you have a fast reader, they just have 2 fixations per line. And then you have this trouble. So it highly depends on the reading skill of the user. And as well, also, we had some trouble beforehand. So the video I showed you was really nice because you could kind of follow along the words read, but usually depends also on the reader how good the resolution is. Sometimes it's shifted up or down, and then you really have to work with the line breaks. And then you get into really difficult situations where you have people rereading sentences. And then we're also not sure what to do. Should you count it again, or is it just trying to understand the sentence and stuff like that? So there's this issue as well. Oh, okay. Yeah.
A short question. First, a great talk. I a lot.
Oh, thanks.
And then will the slides be online?
Yeah, the slides will be online. Oh,
Okay.
sorry, I couldn't put them up. I'll put them on my website, and maybe later tonight. And
Okay.
I'll also put them up on the conference
And
website.
the speed reading, why didn't you put a bigger focus on that in your lecture?
Because this is now something we just starting to work on. So I don't really have too much insights, but this is something I'm personally interested. And also something, the relation between text comprehension or comprehension and learning in general and sleep. There was a reason I showed the CEO sleeping coach and these things, and I'm wondering also about the polyphasic sleep, so sleeping in different, not 8 hours a night, but kind of 2 times 3 hours or something like that, and what it does to learning in general. But as I said, I mean, I don't really have any results yet, so I wanted to get people maybe a little bit excited, but what I can tell you so far is there's not much science towards speed reading out there so far.
What I would also be interested in is like how attention changes the results. Like if you check for people who do meditation, they are known for being able to concentrate for longer times.
Yeah.
And whether they would have a higher comprehension than over maybe 2 hours, 3 hours of reading.
That would be interesting. I mean, I know this, maybe this 10,000 hour rule from this bestseller list or so on. I don't know what the book name is. Anyway, so there's this rule of 10,000 hours. If you study something 10,000 hours, they say you can be an expert, and there are people, I'm not really sure if I should trust this, but I was reading the papers that he cited in the book, and one was really interesting because they showed violinists, expert violinists, in a music school, and they had kind of 3 ranks. One is soloist player, this is the highest skill. One is orchestra player, and then teacher. So these are the 3 levels. And he says in the book that the only discriminating factor between the 3 is the number of hours they train. So soloists train more than the other 2. Way more, but if you read the papers, there's another thing that is different for the soloist players, and that's sleep. So they sleep after training more. They nap during the day. And I wonder, there are kind of two causations. There can be 2 reasons. One is they train really hard, so they feel really tired after training. Or that, sleeping after learning something really helps your memory. And there's some evidence towards this, but it has never been really studied.
So we better get our sleep after the lecture now.
Yeah, of course. Go to bed. Sorry.
One more question,
one more.
I may.
So,
okay.
yeah.
So you also encouraged us to think about consequences for society. So during your talk, I was imagining that my teacher would actually make me wear those glasses and give me a novel, and then check if I actually read a novel, which, in school many books are pretty boring, and then if they figure out I just spent 1 second for each page, then they would probably give me a bad mark because I didn't score. Well, whatever. And so my question is, can I convince you to come up with a license that would prevent teachers from doing that?
That's tough, because I had a teacher in a talk I gave at a conference in the audience, and he was coming up to me afterwards and said, "Oh, can we use this, this eye tracking for the classroom? Because they are already using iPads," and he thought, I want to know how fast people are reading and so on. But I'm also wondering a little bit about if you can fake the reading pattern somehow. If you can, kind of manage to just look at the screen to fake the reading. It's hard. I think it's not really possible, but yeah, I'm wondering about if you can come up with a good idea about a license to prevent this stuff. I would be up for that. Also, I would be really up for, if you imagine you saw what you can do with a small camera and so on, and you're not always sure if the camera is on, so how to prevent that people stream your eye gaze data somewhere. I mean, I'm already feeling uncomfortable having my email or so on out there, but can I get one more, or is it? I'm sorry, we're out of time. Oh, sorry, okay.
Yeah, so
maybe later. So
yeah, probably Kai will stick around and you can ask your questions in private. So thanks again very much.
Thanks.